Measuring short distances. All right. Measuring small and short distances. That's one thing I spoke about your meter rule. And I said that the precision for your meter rule is 0.1 centimeter or 1 millimeter. Those of us that were in class the last time will understand better, and those that watched that very video. So the reading accuracy is about dividing your precision by 2. When you divide your precision by 2, you have your reading accuracy. And then I said these are the possible measurements that we can actually use. You can actually read using your meter rule, right? And after that, I went straight ahead to talk about vernier calipers and the kind of things you can measure using your vernier calipers. I said that anything you cannot measure with a meter rule, you can make use of a vernier caliper. Example, measurement of external diameter, internal diameter, and the depth of a particular object, right? And I gave examples of the diameter of such objects, right? All of them are written right there. And I shared this very slide. I'm going to share it again at the end of the day. So precision for this one is 0.1 millimeter or 0.01 centimeter. I said for me, I always want to remember millimeter, 0.1 millimeter, right? Then if you convert millimeter to centimeter, you have 0.01 centimeter by dividing millimeter by 10. So meter rule, 1 millimeter. Vernier caliper, 0.1 millimeter, right? So this is the reading accuracy by just dividing it by 2. And these are the possible measurement. For this one, you have 1 decimal place, 2 decimal place, as the case might be. So all of these things are the stuff that I spoke about the last time. And then I spoke about micro screw gauge, right? Micrometer screw gauge. That's an error here. So, and all of these things are the precisions and the reading accuracy. Now, fast forward to how to read your vernier calipers. Yeah, this is a summary of what I gave. So I said that when I have 1 centimeter, right, this is what is going to be as the case implies. So meter rule, your vernier caliper, your micrometer screw gauge. So these are the key things about them. And I didn't stop there. We went ahead to read your vernier caliper, right? And let me brush through it again for those that we are not in class that very day, right? So brushing through, I said we'll have the vernier scale because it's going to help us to learn how to read your micro screw gauge. So now I have the main scale, right, of your vernier caliper. Now, the main scale is the one up, the vernier scale is the one down. So how do we read the vernier caliper? The first thing you're going to do while reading the vernier caliper is that you have to read the main scale, and the main scale is just the line you are going to see before the zero of the vernier caliper. So if you look, this is the zero of the vernier caliper. So that particular value you're going to see before that zero of the vernier caliper or the vernier scale, I mean to say, is where the value is. This is the vernier scale, the one down. And it happens that the one up is in centimeter, which is your main scale. Then your vernier scale is in millimeter. So that very point you're going to see before the zero mark is your vernier scale. So now is your main scale rather. So the main scale here is 10.6. Here is 10. When you read through to that, you're going to see that the main scale is 10.6. And after that, the second step is that you are going to find the vernier division that aligns perfectly with the main scale. What does that imply? You go through the vernier caliper, look for a place where they are aligned properly. You can see that this line crosses over to this side. That's exactly where it's crossed over. So that line that it crosses over is your vernier division. And you can see that the corresponding value at that point in time is 5 millimeter. And that's how we say that the vernier division is equal to what? 5 millimeter. It doesn't end there. Then the step 3 is now to multiply this vernier division by the precision of the vernier caliper. So now vernier caliper reading is 5 millimeter. The precision, like I explained earlier for vernier caliper, is 0.1 millimeter. So therefore, the vernier reading is going to be what? 0.5 what? Millimeter. And after that, the last point is that you're going to add everything together. Add the main scale and the vernier reading together. Once you do, you're going to get a total for that. And we solved other examples. So do well to go check them out. I gave a summary on that. So today, we're going to continue with how you can read your micro screw gauge. Any questions so far, guys? Any questions so far, guys? We agree that all of us are on the same page. Any question, guys? Nobody's talking. Okay, that means everybody's smart now, and then we understand everything. If you have questions, you ask before we proceed to the next. Anybody? All right. That means forever remain silent. Now let's look at your micro screw gauge and let's see what we can use the micro screw gauge to do. So how do we read your micro screw gauge? It's just the same thing as your vernier caliper, right? Just a little difference here and there, right? So now reading micro screw gauge. Micrometer, please. So now in reading your micrometer screw gauge, we're going to follow the same step that we used for measuring your vernier caliper. Nothing in particular changes. Now, for your vernier caliper, sorry, for your micro screw gauge, it has two parts. We have what we call the sleeve, right? We have what we call the sleeve, and we have what we call the thimble. I might not have pronounced correctly, but at least I can spell it. Now, the sleeve is more like your main scale. Just like I'm trying to adapt what we use for our vernier caliper. It's more like the main scale. While the thimble is more like your vernier scale, right? Making reference to what we learned from from vernier caliper. So that's exactly how it works. You could see something like this. Your micro screw gauge. Oh, wait, before I start the reading, did I highlight the key things you can read with micro screw gauge? Did I do that? Yes, I did. So today is just about the reading of the micro screw gauge. All right. So now you could have the micro screw gauge can just be this way. You will have something like this, right? You have a line this way. It might be too big, but then the main thing is to accomplish our goal. We'll have something like this. Then it could just go this way, right? Then go like this. Then this side could just go this way, right? And then go this way. They are going to have different lines, line map on them, right? They're going to have normal lines. I'm going to download one of them so you can see. You're going to have lines this way, line this way, including this side is going to have its own reading, right? So here is this is the sleeve, which you can also call altogether the main scale. So this is your sleeve. This is your sleeve. And then this side is your thimble. That can be likened to your main scale and your vernier scale from a vernier caliper. So that's just what the process looks like. So let's see how we can read your vernier, your micro screw gauge. No. So steps for reading now. So steps for reading your micro screw gauge is just the same process as of reading your vernier scale. Steps for reading micro screw gauge. So how do we read? We have three key steps. So the first step, just like your vernier caliper, the first step is that we're going to read the sleeve. Read the sleeve. And reading the sleeve is simply about reading the main scale. So the sleeve is the main scale for your micrometer screw gauge. This is the main scale. So now, after I must have done that, I'm still going to break it down into, when I'm solving examples, I'm going to break it down just that way. So now the next one, I'm going to read that very thing that I mentioned, the thimble scale, which happens to be the vernier. I call it the vernier scale, just for us to understand, right? Which is the vernier scale. Right. Then the third one, we'll do what? We'll multiply the thimble reading by the precision. Multiply by the precision of a micrometer screw. And who can remember what's the precision for screw gauge, micrometer screw gauge? People that were in class the last time, people that watched the video. So what's the precision? 0.
0.01.
Yeah, that's justice, right? 0.01 millimeter. Is that also precision of a micro? Always put the units, whether it is centimeter or millimeter. So thank you. Micrometer screw gauge. All right. So after you must have done that, the last step is to do what? Is to put them all together. So you can now go ahead and add them together. What are we adding together? Right? You are adding the main scale plus the main scale and the vernier scale. That's exactly what we're adding together. Main scale plus the vernier scale. And with that, you have your answers to the reading for your vernier, for your micro screw gauge. So now we're going to solve some examples on that so that we'll see how best to go about it and how to read your micro screw. Mike, I don't know, I keep repeating, making mistakes. Micrometer screw gauge. I don't know why I keep making that error of not calling it properly. All right, so that being said, let's have an example. So you give me a few minutes. I would like using real-time questions to do that. Real-time questions. If you are following, can you give me a thumbs up? So far, so good. If you are following, give me a thumbs up. So far, so good. All right. And Justice, okay. Anointed, Mesoma. Who again is on the call? Have not given me a thumbs up. I think um let me see. Stephanie. Who is Mide? Okay, Anointed, you are the Mide, right? Then Kukumo. Forgive me. Forgive me for murdering your name. Forgive me. So, sorry about that. I'm staying very close to the road at the moment. I have to find a place where there is lights. Okay. All right. So let's take these questions and then let's read them accordingly. Right. Also, do well to go online and get as many questions as possible so that you can as well practice, right? So you can as well practice. So that's how we do it. So after this read, I'm going to go straight to dimensioning. And after dimensioning, we're going to take a general quiz that I believe everybody should participate. And we should have a gift for the person that wins at the end of the day. All right, I think this one works. But it's not too clear. We need something a bit clear. Okay. So I didn't remember. I have downloaded this before now. All right. So let's put an image on this. All right. Confirm you can see my screen now. Okay. All right. So imagine this now that we want to read this micro screw gauge. Can you see that now? How many of us can see that micro screw gauge? Right. So this is what we have right here. So the first step, what's the first thing I'm going to do? Right. The first thing I'm going to do is that I will check for my main scale reading. Remember what I said? We're going to check for our main scale what? Our main scale reading. And now the main scale reading now. So step one, we'll check for our main scale reading. You can't see my screen?
Yes.
Are you serious? Oh, sorry. I was thinking I'm sharing my screen. I think I'm getting old. Sorry. Can you see the screen now? All right, beautiful. So sorry, that's old age. And so sorry for the delay as well. So let's move with the speed of light. So the first thing you can see, they have 0, 1, 2, 3, 4, right? Now, the step one, check for your main scale. So step one, we'll read the main scale reading. Is that also? So main scale reading. Men and brethren, remember what I said earlier? Huh? I told you guys before, that's what I said, that this side is your main scale. Is that also? This is our main scale. If you don't forget what I talk, raise your hands up. And then this side is your what? Is your vernier scale. But you know it's wrong to call it vernier scale. I'm just saying that because we've learned vernier scale, caliper already. But in the real term, this is your sleeve, the sleeve scale, and this is your what? In the actual sense, and this is your what? The thimble. Please take note. I'm just using vernier scale and main scale for us to understand faster. So let's read accordingly. Remember, this is in millimeter. Can you see that? That guy is in millimeter. So I'm going to read now. So this is 0. Here is 0, 1, 1. This is 0, 0.5, 1. Let me zoom this. For some of us that have drank Gary so much, I know plenty of you are in this class and you cannot see very well. This is 0, 0, 0.5, 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. You can see that very last line right there. That's your main scale reading. So that's your main scale reading, and the main scale reading right there is your 4.5. And because I'm sending this slide to you guys, I want to make it as clear as possible so that even when you're going through on your own, you will not be confused. So step one said we should tackle our main scale reading, and because we are tackling our main scale reading, what I'm going to do now, I'm going to represent the particular value on that very place. So main scale reading, let's look for the value on our main scale. So I'm cleaning all of this thing, and you can see that on our main scale, that will have a specific value there, and that value that we have is right here. And the corresponding value here is what? 4.5 millimeter. That's your step one. Then the step two, we are going to check out for what? Our what? What do you call it? The tempo now. Let me clean this up so it doesn't interfere with the place where the whole thing crossed. Right? Um here is where the corresponding value is. Now, the step two is to read the vernier scale. And that simply means that place where it crosses over. So step two, we are to read, let me call it the name. Let's read the thimble, which happens to be what I call your vernier scale. The vernier, right? Let's put it just that way. So now, and in reading that one, you're going to see just like in vernier caliper, where there is a crossover, like more like there's a place they crossed over, and we're going to look for that spot together. All of us will look for that spot together. Let's look for that spot together. A place where there was something like that they crossed over. So let me quickly erase this one so that we can look for that very place. Now, check properly. Who can show me a place where there is an intersection between the first one and the second one where the line crossed over? Can anybody see that? Anybody?
Yeah,
Yeah,
is
okay.
between
Justice, go ahead.
the main scale, the line that follows from the main scale to the symbol scale.
The line that follows from the main scale to the tempo scale. You are making reference to this one, right?
Yes.
Yeah, you will make heaven. All right. Beautiful. Well done, Justice. So you can see that is this very place. Some persons are in the class now, they are confused what Justice said. I know some persons are. Look at that very place. You're looking for the place where, some of you that don't stay at home, you are always crossing to somebody's house. So that line where it crosses to that person's house is what we are looking at. So the main scale does not stay one place. It wants to move. It go just cross. This does the line. There's a line here. Are we together? If we are together, give me a thumbs up. Give me a thumbs up if we are together. Yeah, makes sense. Thank you, guys. So now, what will be the corresponding value there, my brother? What will be the corresponding value there? We have here is 10, here is 5. So what do you think is the corresponding value there?
1.
You said?
1.
You said 1. Okay, we have 0, 1, 2, 3, 4, 5, right? That's beautiful right there. So the value there is what? Is 1. God bless you, Justice. You're doing well. So we'll have a corresponding value at that very spot where the line crosses over to the other side. Let me just represent it by drawing a line right there. And that is what? That is 1 millimeter. But remember that we don't just stop there, right? Once you get the reading of the venia of the tembo, we're going to, so who knows how to pronounce that thing? Help my life, please. Those people that know how to speak phonetics very well, that speak very well. So what's that? What's the name of that thing there? What's the name of that scale? Anybody? Okay, nobody wants to talk. So let me continue calling it what I call it. Now, multiply the thimble reading by the precision. By the precision. Anna, are you still with us? Anna, confirm you are still on the call with a thumbs up. Chinonso, are you with me with a thumbs up? Which other name again? Okay, Mesoma, thank you. Anointed, are you here? Anointed, good. Stephanie, are you here? Yeah, Ferrami, thank you. Stephanie, are you here with a thumbs up or are you eating? So let's multiply. Yeah, Stephanie, well done. So let's multiply the tempo reading by the precision. So the tempo reading is what? Is 1 millimeter, right? So we'll have 1 millimeter. Someone should tell me what the precision is for micrometer. 0.01 millimeter. Is that also? So when you multiply this, I've told us we need our calculator in this class. So, but you should be able to multiply this without your calculator if you're serious. So just give us value. What will it be? Anybody? Very fast, very fast, so we can move.
That's 0.01.
You said
0.01.
what? All right. God bless you. If you want to talk, raise your hand. I will start capturing your voice. Okay. 0.01, right?
Yes, sir.
Good. Yeah, 0.01 millimeter. Makes sense. So now step 4 says what? We should now bring them what together. Is that also? We should bring everything together. So step 4 says bring everything together. So step 4, we are going to have our sleeve, the sleeve plus the thimble. What's the value for our sleeve? If you can still remember, sleeve was what? 4.5, right? Good. 4.5 millimeter plus 0.01 millimeter. So that the micrometer screw gauge reading, micrometer screw gauge reading, will now give us what, our brethren?
4.51 millimeter.
4 points is equal to what? 4.51 millimeter. God bless you. Are you sure? Now, someone should quickly make reference to the values we spoke about. Are we there? Can someone quickly make reference to the values we spoke about for the decimal place? Remember that for millimeter, in terms of your meter rule, we said it should be 1 decimal place. The corresponding value should be 1 decimal place for meter rule. That's the kind of reading you can get with meter rule. Then we said that the kind of reading I should get with vernier caliper should be 1 decimal place. And the kind of reading I should get with my micro screw gauge should be 2 decimal place. So that tells you that this answer is actually correct. If you understood what we did, can you raise your hands up, please? Don't be shy. Feel free. Right? We're all learning. Any question? Yeah. Anointed. Anointed, are you the person that says BTC? Maybe you should send us money. Stephanie, what's up? Stephanie, I'm not seeing a thumbs up. Are you sure you are following? Stephanie, I'm calling you twice to know whether you're following. Okay. Anointed BTC. Well done. All right. So No, there's another person here. Mide, are you on this call? Or you are trading BTC? Okay. Now, someone said I should explain the diagram again. Okay, let's go. Now, remember that for your micrometer screw gauge, a very quick one, right? That we have two parts of the diagram. We have the sleeve. Are we together, guys? We have the sleeve. We have the sleeve, and we have the thimble, right? Which I break into main scale and vernier scale, right? So now, and if you check for the other one, what we do, English on the hard. If you check the other one we do, you go see say we get the vernier scale and the main scale. So I'm trying to blend them in so that you can see a sync between the previous one and this one. Does it make sense? Now I want us to see a sync between the sleeve and the thimble for your micrometer screw gauge, right? But it can be likened to your main scale and vernier scale for your vernier caliper, right? So, and I said that for you to read this micrometer screw gauge, you have to first of all consider the sleeve. There's a part called the sleeve and a part called the thimble. You have to look at these two. So first of all, you're going to read the main scale, which is the sleeve, and read the thimble, which happens to be your vernier scale, as the case may be. Then when you do that, you now multiply that vernier reading by the precision of micrometer screw gauge, just like what we did for our vernier scale. That will multiply the vernier reading by the precision of our vernier caliper, right? So add them together, the main scale plus the vernier scale. So that was the question they gave us, and then we had to break it down into what our main scale, which is the sleeve, and the vernier scale, which is our thimble, right? So step one says we should mark out our main scale reading. So this is our main scale. The value here is 4.5 millimeter. So if you check the last line there is what you're going to read off. The last line on the sleeve is your 4.5 millimeter. Somebody's mic is on. Anointed. Do you want to prophesy? It's not your time, please. Now, for the reading, you can be good. For the reading, who again? Someone else? Your mic, okay. Yeah. So reading the thimble now, which is the vernier scale, we have to find a point where the sleeve crossed over to the thimble. Look at that very line. You can see that there's a line where it's crossed over. This is the only place where it's crossed over. So that place that it's crossed over happens to be your what? Your thimble reading, right? So that place that there is a crossover, this is your thimble reading, and that is 1 millimeter. Does it make sense? Yeah. So we read from that very graph, and then we multiply by our thimble reading, and then we added the sleeve and the thimble together, and that gave us the value for our micro screw gauge reading. Does that make sense now, Emmanuel Chinonso? That's the Chinonso. Does it make sense now? Okay, beautiful. So I'll solve more questions on that. So let's download more and solve more questions on that. And I hope we are writing. In as much as you are depending on my slide, it's also important you have a note where you are writing, because there are some things I say that might not be on the slide, that not even might, that is not on the slide. So it's important that you do well to put them down. All right. So let's get another question, as the case might be. Someone said same here. Same here means you're writing. Okay, sorry, that was before, not now. All right, guys. So another question. I'm going to do 3 questions on this, just 3, and we are good to go on that. Then I talk about how to measure mass and weight. All right. I've done one of them. So let's do another one, guys. Hope we're enjoying the class. If you're enjoying the class, can you give me a thumbs up? All right. Beautiful. Beautiful. Okay, so I'm trying to download the second one so that we can read off accordingly. As many as possible. I want to do that. All right. So I want to do just 3 questions. Just 3 questions. All right. So our image, I have 2 questions I will need to solve. Let's do this one. Let's do this one, guys. Okay. Confirm you can see my screen. Okay, interesting. Anna, your hands are up. Any problem? All right, so let's read this one as well. But this time around, I'll not be saying steps again because I've highlighted the steps already, so we can save time. So as always, our step 1 is to read our what? We are reading the what? The main scale, right? So what's the value of the main scale right there? So let's check. Here is 0. Somebody should tell me. I shouldn't be saying it at this point. Who can give me the value of the main scale, like on the sleeve? What's the corresponding value on the sleeve? Someone should give me the value on the sleeve, please. Anybody who can attempt to give us the value on the sleeve? Anybody? I should call names. Anointed.
Okay.
Justice, you said what?
I think it's 3.25.
3.25. What does each line represent? Let's start from there.
I think each line represents. First one represents 2.5, second one 5, and then third one 7.5.
Makes sense. What do you mean by 7.5? 0.75. So now look at how you can know what each line represents. Men and brethren, anointed and co. How you can know what each line represents. I know some of you don't know. You just want to swallow it and force in your men girls. Now you count the number of lines. How many lines do you have? 1, 2, 3. Okay, let's start. This is 0. You count 1, 2, 3, 4. You have 4 lines before you meet the next one. I go again. 1, 2, 3, 4. Now far for your side. They wake up by to 11. The file no trial. So you have you have 1, 2, 3, 4. Are you there now? So this is the 4th line. You get again 1, 2, 3, 4. 1, 2, 3, 4. So before you get the next line, you have 4. You count 4 lines before you get the next one. So how will you know what each line represents? Remember, you are counting in 1, 0, 1, 2, 3. So you are increasing by 1, 1. So what you are going to do, you are going to say 1 divided by 4, which is equal to what? 0.25. So it means that each line is 0.25, right? So which means that this is 0.25. 0.25 plus 0.25 will give us what? 0.5. 0.5 plus 0.25 will give us 0.75. 0.75 plus 0.25 will give us 1. Justice, is that also? Justice, is that also?
Yes.
Beautiful. So the next one, 1.25. 1.25 plus 0.25 will give us 1.5. Just that way. So each line represents 0.25. So you cannot do it with your head. You can use calculator, right? So 0 plus 0.25. If you understood what we said and what we are doing, give me a thumbs up now. Beautiful, anointed. Anna, Anne, BTC. Please, what's your full name? When you are joining the class again, use your full name. BTC, what's your full name? Type on the chat. Let me see. Mide BTC. Is there your Mide? Daniel. Okay, he's not talking. I can't hear you. So each line is equal 0.25. So which means that our main scale reading here, like my friend rightly said, Justice said that here is 3.25. So the corresponding value here is 3.25, right? Millimeter. Any question on that, guys? So men reading, Stephen, you're not saying anything. Or maybe you've learned this side before. Main scale.
Sorry, sir, I'm not really following. I'm actually somewhere.
Okay, you went to market to buy bread.
No, actually, I went to register for JAM, so I've not left the place.
Oh,
I'll go back to the
okay,
video.
okay. All the best. When you get to home, you can answer. The recordings are there for you. Okay.
Yes, sir. Thank you, sir.
Yeah. Okay, so this is our step 1. Can we proceed, guys? Now, our step 2 at this point. Are we following, guys? So our step 2 now, Ferrami, right? Ferrami, did I pronounce your
Yes,
name?
sir.
When you come up, you pronounce better. Good. Can you give me, I'm trying to go to step 3, my step 2, and that step 2 is the Tembos reading. Can you give me what it should be?
Thirteen millimeters, sir.
13 millimeter. Well, let me zoom in and see whether do we agree with her? Is it 13 millimeter, guys? Yeah, Justice is giving a thumbs up. Anna, don't just give a thumbs up because others are giving. I did that back in school. Is the answer correct? You don't even know the correct answer. You could just shout yes. Because if you say no, they will tell you to say the correct one. So you just have to agree that it is correct. Move just they go. All right, thank you, Ferrami. It is 13 actually, because we are looking at that very line here. We are looking at that very line here, right? This is 10, 11, 12, 13. So there's a corresponding value here, and that is our 13 millimeter. Now, who again is on the call? Anointed, man of God. Anointed, what is the next step? Anointed, what is the next step? Anointed has turned deaf and dumb. Mesoma, what was the next step?
You multiply it with the precision.
So what is the precision? What's the precision for your micro?
0.01 millimeter.
Okay, good. So we're going to do 13 millimeter times by 0.01 millimeter. And when we multiply, what will it give us?
0.
Who again is 0. What?
13.
0.13 millimeter. 0.13 millimeter, is that also?
Yes.
Good. Then our step 4, we just add them together, is that also? So we'll have the other scale was what? 3.25, right? We'll have 3.25 millimeter plus by 0.13 millimeter. So what will be our answer, guys?
3.48.
No.
3 point what?
3.38.
Okay, this will give us 3.38 millimeter, right? So that means that our reading for that very guy, good. Mesha is giving you a thumbs up. So micro screw reading is equal to 3.38 millimeter. And that's it, chicken. Abinobiso. Yeah, thank you. So you've seen step by step how we can actually read our micrometer screw gauge. Now, the last example for those that are not following, let me add up the last one, and then we'll call it a day for micrometer screw gauge. Then I look out how you can measure your mass. All right. Let's look at another example right here. So on a good day, all of these things should have actually been placed on your slide. But you know how life can be. Which one? We've done the one of which one do we does it now? I think okay. Let's look at this one, right? So done right here. Okay, so example 3, right? Good. So who can tell me what the line there represents? What will be the value right there? Remember that you have to start with 1, just that way. So who will tell me the particular value we have on the main scale reading right there? So what do we have on the main scale reading?
I think it's
Anybody?
3.
Do we agree? Anointed, you've not said anything. You're just good at giving me thumbs up. You're just giving me thumbs up. Any small thing, you give me thumbs up. Can you please give us the value for that very stuff? And Titiola, they're not saying anything. Titiola, what's the value for the main scale reading?
3 millimeter.
3 millimeter. Are you sure it's 3 millimeter?
Yes, sir.
Okay. Okay. Anointed. You should be the one answering every question because you're anointed. You have double anointed. Even before I solve the question, you should be giving us answers because you're anointed, but you're not saying anything. Huh? Young man. All right. So step 1, the main reading. So I agree that the main scale reading is 3. All right. So now, Titiola, you've highlighted that. Sorry, I think the best thing to do so that we don't make mistakes. Because towards the end of your exam, now all of these things you might forget them. So let's just keep maintaining our slides very well and not assume that everybody understands it, right? So, Titiola, as I'm doing all of these things, I want you to give me that of the Venia reading, which is your Tembo reading. Can you just give me that one as well? We need it.
21 millimeter.
21 millimeter. Beautiful. All right. I think I have smart guys in this class. Maybe next week I will not teach. People will come and teach. What do you think, guys? we have my very smart guys in this class. All right, so let's check. You said 21 millimeter, right? Titiola?
Yes, sir.
Okay. Titiola said, okay, step 1, she said, first of all, we said that the main scale reading is what? Is 3 millimeter. So she said the other one is 3 millimeter, right? Then our step 2, we're looking at, is she correct, please? Step 2. Okay, Justice gave you a thumbs up. Okay. So that was a Tembo reading. Right. And we all agreed that we have what right here? We all agreed that we have 22. Huh? Is it 22? 25. 25 is here. So 20, 21, 22, 24. Are you sure? I disagree, guys.
It's 21.
21, right?
Yes.
Justice, you are fired for agreeing with 22.
Oh, no, I said 21.
I agree with you. Like you said 21.
Who said 21? Was it 21?
Yes.
Oh, sorry. No, I'm getting old. You're not blame me. So we have what? 21 millimeter right here. So Titola, give us our final step, which is our step 3.
Okay, so multiply the reading on the symbol by the precision, which is 21 times 0.01. And then
okay, now someone has decided to teach me the Timbo. I was calling it Tembo. You didn't want to talk all this while. No problem. God will judge our matter. So now, step 3. What is the precision for your micro screw gauge, Titola?
0.01 millimeter.
0.01 multiplied by 21. And that will give us what?
0.21.
0.21, right?
Yes, sir.
BTC, you keep joining and leaving. What's happening? So that's step 4. The network is bad. Okay. Maybe is there any tree close to you? Titela, mute yourself, please. Titela, you can mute yourself. Is there any tree close to you, BTC? If there's a tree close to you, see whether you can just climb a little bit. It's going to help you. So you have 3 plus 0.21. So that will give us what? 3.21 millimeter. So that our reading is equal to 3.21 millimeter. All right, so that will be our end of micrometer screw gauge reading. As always, I've highlighted the steps. So are you following us? I've highlighted the steps. Step 1, check your mesh scale, check your vernier scale. Always remember to multiply that by 0.01 for micro screw meter screw gauge. Always remember to multiply by that. Right, so so far so good. We've handled our meter rule. We've handled vernier scale, vernier caliper. We've handled micro screw gauge and what you can measure with them. Then we've actually done the reading of vernier caliper. We've as well done the reading of your micro screw gauge. Right, so these are the key things that we've decided to pay attention to. So now the next thing I want to look at is the measurement of what? Of mass and weight. Are we together, guys? Measurement of mass and weight. And if time permits me, I'll also look at measurement of volume. Then we'll go straight to dimensioning. So let's look at measurement. The measurement of mass and weight. Remember that physics has 40 topics. 40. This is just the first one. And we have barely how many weeks? So if you're not reading on your own, I don't know what to tell you. So now we have mass here. So for your mass is simply, mass is at the center now, right? So mass is simply the amount of matter in a body. Are we together now? Your mass will give you the what? The amount of what? Matter in a body. That is what the mass will give you. Are we following? Mass gives us the amount of matter in a body, right? It is measured in what? In kilogram. Is that not so? Mass is measured in kilogram and is the amount of matter in a body. Now, it is what can we measure mass with, right? So it is measured with what? Beam balance. Measured, all these things are exam questions. Measured with what? With what we call beam balance. Have you seen a question where they said we can measure mass with what? They will put beam balance. They will put there's this one they normally put for weight, spring balance. Exactly. So we measure your mass with what? With beam balance. So now the next thing you need to know is that mass does not change with location. Mass doesn't change with location. It is the same everywhere. So mass remains what? The same. It is same in the moon. It is same anywhere, any planet at all. Your mass is still the same. Jam question can ask you. Sometimes you can see something about mass changing and the rest of them. Which one will change, right? Which one remains the same in the moon, right? So mass is same in the moon, same on Earth, same everywhere, same mass on Earth, same moon, the same anywhere. So these are the fundamental things that we need to know about our mass. The amount of matter in the body is measured in kilogram. you can measure it using a beam balance, and the mass does not change with location. So mass is the same anywhere in the world. In any planet, the quantity of matter in you does not change no matter the location. So the next one we should talk about is our weight, right? So sometimes we mistake mass. Sometimes we mistake mass with weight. Is that also? Sometimes we mistake mass with weight. So this is about weight. So for your weight, weight is the gravitational force on a body. Weight is the gravitational force. Weight is the gravitational force. Is the gravitational force on a body. Weight is the gravitational force on a body. Are you there now? Right? Or gravitational force acting on a body. I think that's a better way to write it. Gravitational force acting on a body. Are we there now? So the next thing is that how do we estimate it? Remember your formula for weight. You always say that W is equal to what? Mg. Is that also? Where G is the acceleration due to gravity. And the weight will change with location because G changes with location. Are we there, guys? A thumbs up if you are following. So this G is acceleration. Acceleration due to gravity. Is that okay? Right. And it's measured with spring balance. Measured with spring balance. Which other thing should I put? Yeah. It changes with location, right? It changes with location. It changes with location. Because of why does it change with location? Because it depends on what? Gravity. It depends on what? It depends on what? Gravity. Depends on gravity. So because it depends on gravity, take note that something will weigh less in the moon. Do you understand it? Are we together? It will weigh less on the moon. Yes. Right. Right. Why? So for the moon, your G is equal to 1.6 meter per second. Then for Earth, G is equal to 9.8 meter per second. So what that means is that you weigh more on Earth than on moon. You weigh more on Earth than moon. Is that okay? You are expected to weigh more on Earth than on what? Than on moon. Any question on that? So these are the key things about. They can ask you what's the difference between mass and weight. The key difference between mass and weight is that the other one changes with location, while the other one does not change. And remember that what's the formula for your mass? It is measured what? In Newton, right? It is measured in Newton, while your mass is measured in kilogram. All right, guys. Any question on that? Any questions so far? I believe everything is clear and that we are putting down some things. So we measure mass using your what? Your beam balance. We measure weight using your spring balance. Tiola, are you here? Mide, are you here? Chinonso, are you here? Who again should be on the call? Stephanie is doing her jam registration. Justice, are you following? Ferrami, good. So these are the variables for your mass and your weight. Now, talking about the measurement of solids, there are different ways you can measure volume. right? And I want to leave that to you, how you can measure volume. But I will continue. If I have time, I'm going to talk about measurement of volume, right? How do we measure volume even? You can have a regular subject, a regular solid, and an irregular solid. A regular solid is the one that the volume is known. So you can actually measure the volume directly. But if you don't know the volume of the solid, what you can do is that when you place the solid inside water, it will displace an amount of volume, amount of water. That amount of water it displaces will give you the volume of that solid. Anybody? Do you understand what I'm saying? Do you understand what I'm saying? If you do, give me a thumbs up on in terms of measurement of volume. Good. So, Anne, if you understand, can you explain for them? Explain for Justice. Titiola,
So,
can you go ahead and explain for Justice? Can you go ahead? Justice said he doesn't understand. Can you please explain for him?
I don't know how to explain.
That means you do understand it.
I don't know how to explain it because I don't know. I
You
don't
don't
even know
know.
how to explain myself.
All right. So let's see. Now, you know that volume is measured in different capacities. You have 1 liter is 1,000 centimeter. I believe that you guys should know that. Is that not so? Hmm? I believe, I know how about what do you call it? Okay, look at what I'm saying. For measurement of volume, let me just quickly do a brushing on that. Measurement of volume. Then you should know your conversion and you should know the volume of different shapes, right? Measurements. But remember, I didn't plan to teach you volume. I said I'm going to give that an exam assignment, but I don't know why my heart is so soft. Huh? It have been an assignment. So measurement of volume. Now, for a regular solid, you can easily get the volume. When I mean regular, something that has shape. But for an irregular solid, a solid that doesn't have shape, what did I say? Irregular what? Solid. So there are different ways, but I want to talk about the displacement method, right? So the method I want to talk about here is your displacement method. And that is for what? Irregular solids. Now, when you have an irregular solid, what you are going to do typically is to get the volume. Are you listening now? Is to what? Get water, get a measuring cylinder, right? What are the instruments that we need? Get your measuring cylinder. If you went to a good school, you should know what measuring cylinder is. But if you went to a community secondary school, may the Lord grant you understanding. Now, but if you went to a good school, like my own school, you should have a measuring, you should know what a measuring cylinder is. It's usually like this. Well, if you've not seen it before, even when I draw it, you'll not even recognize it. Usually like this. So those that went to a good school, have you seen this before? It seems all of you didn't go to a good school. How many persons have seen a measuring cylinder before? So once you have that measuring cylinder, you can actually measure a particular amount of. I know Titiola have not seen it before. Titiola, don't mind me, I'm joking. All right. So when you have a measuring cylinder, you pour a specific amount of water into it. Now, when you place that solid inside of it, inside that very water, it's going to pour out an amount of water. Let's say you fill this very measuring cylinder to the brim, like up to the brim. Then you put stone inside of it, a irregular solid inside of it. You remember that some amount of water is going to be poured out. It's going to displace some amount of water. Do you understand? So that amount of water that it displaces will give you the volume of that solid or that object that is irregular. So what I'm trying to say that for that irregular solid is that the volume of water displaced is equal to the volume of the solid. So volume of the solid equal the volume of water displaced. Do you understand what I'm saying now? Do we understand now? And people that went to a better school has come again. Someone said concave flax. Okay, now. People that went to better school. Okay, might be a concave flax, my brother. So there's something we normally do as children, you know. I know you guys didn't do it. You have water inside a bowl, and sometimes you see yourself stepping inside of it. And when you step inside of it, you see the water pouring out, like some water amount of water will be poured out. That is exactly what happens with a solid. When you bring an irregular solid and solid chip, and you place it inside water, it will displace an amount of water. That amount of water it displaces is equal to the volume of water displaced. Sometimes you can also actually see this in terms of floating, but let me not go there. So these are the kind of questions you could always see. And remember the volume of cylinder. These are the kind of things you're going to see, right? Key things you should know. Recall volume of cylinder, because sometimes you might see question along that is pi r squared. Volume of cone, I think should be 1/3 pi r squared h. Someone verify that cone for me. Am I correct? Is it pi r squared h? Volume of cone. Then someone should verify. Google. So volume of sphere, I think should be 4/3 pi r squared. Verify these things I'm writing. Is it pi r squared or pi r between 2 or square root? Anybody verifying for us? So you should take note of all these shapes, especially these ones I wrote down. Then volume of a sphere, of a hemisphere, should be volume of a sphere divided by 2. Anybody helping us out with the real data, please? Do you have a helper? Any human being doing that for us? Okay, so quickly check volume of a cone. I don't know. It should be 1/3 pi r squared, but I need to verify that squared, whether it is 2 or 3. But I know that this one is either 2 or 3. I can't remember. So verify and get back to us. So these are the volume of the plane solids. You should always, at every point in time, remember. Anybody that have done that? You guys, this class, I don't understand. So nobody can minimize and check on Google.
The volume of the sphere is 4/3 pi r cubed.
Good. So, but others are correct, right?
I'm not sure.
Others, okay. So others can verify. But the volume of a hemisphere, I know you're going to divide the volume of sphere by 2. All right. So when you verify, let us know. So that said, let's go to dimension of quantities. The dimension of physical quantities.
The volume of a cone is correct.
Okay, thank you, Justice or Anointed. Anybody that talked? So dimension of physical quantities. Now, for the dimension of physical quantities, we'll be making use of key guys, right? Which is what? M, L, T. Remember that M represents your mass. Sometimes they want us to put the units, that's kg. L represents your length, which is in what? In meter. And T represents your time, which is in seconds. Now, they can ask for the dimension of physical quantities. So now, for example, we know that velocity, I'll just give you a few of them. I want us to take our quiz very soon. We'll have that velocity is what? Displacement all over time. Now they want us to get the dimension for displacement for velocity. It simply means that anywhere I have distance, I should have my L all over T. So that is equal to what? LT minus 1, right? Or L over T. Remember that this minus 1 is coming up from your indices. I don't want to go there, but I know you know your indices, right? So the next one is acceleration, and that will do for force and other ones. So the main thing there is that you cannot get the dimension of a quantity that you don't know the formula. So this one is velocity all over time. If you're not good with mathematics, you might struggle a bit with dimensioning, right? So we have velocity over time, and velocity already is LT minus 1. Are we there? So because this one is dependent on your knowledge of indices. If you know your indices very well, then you're certainly going to do well in this. So acceleration now is going to be equal to, have velocity to be what? LT minus 1 all over what? All over t. Now, this same thing I'm saying LT minus 1. Hi, God help me. I hope you guys know mathematics. Then I'll bring this t up. It's going to give me another minus 1. If you understand how that minus 1 came up, raise your hands up. God help us. I believe they are good in maths. Good. And good to go. Mesom, what's the challenge? Justice, yeah. Do you know how we got the minus 1 climbed up? Good. Very smart guys. Thank God for that. Very smart guys. Ferrami, do you know how that minus 1 climbed up? I make I carry and come down. Okay. Yes, now let me know whether I should carry it down, But since she knows, no problem. So that means that acceleration now is equal to what? LT minus 2. Hope I'm safe. We are good to go, right? LT minus 2. We agree. We agree, right? Good. Makes sense. Everybody will agree. Anointed will agree. All right. So the next one, I've done acceleration. The next one I want to do now is your force, right? Because these guys are the key guys. So force is equal to what? Your mass times your acceleration. And let me give you a hint. There are those ones you should always have offhand or off heart. I don't know how you guys call it. But there are those you don't need to solve again. You should just know that this is what it is. Example, force is MLT minus 2. You should always bear that in mind. Force is MLT minus 2. So the mass is what I measure. Anywhere I see mass, I write L multiplied by acceleration is LT minus 2. So in the exam, you're not expected to start deriving for force again, especially when you're looking for a particular quantity. So it would be an error for you to start looking for force again because you don't have the whole time in the whole world. So always these ones should be at the back of your mind, right? That is Nigeria for you. Outside there, nobody wants you to cram any of these things. They give you your formula sheets. But then we are very strong people. We want everything to enter inside the head. So we have the force right here. That's our force here. MLT minus 2. Now, the next one can be impulse. Now, impulse, the formula for impulse, and there's a question they normally ask you, which one have the same dimension? So impulse is simply what? Force times time. Times velocity? Wait. No, momentum is mass times velocity now.
Impulse.
Can someone quickly verify, please?
Impulse and momentum have the same dimension.
Yeah, they have the same dimension, but they don't have the same formula. Yeah, they have the same dimension, but they don't have the same formula. Someone verify for us. Smart students in the class, everybody. Momentum should be force, impulse should be force. Let's just continue. We're going to verify. So momentum is force times time. So that impulse is force times time. So that impulse is equal to that. I'm getting over their formulas I might not be able to forget. So that will give us LL minus 2 times by T. Now, impulse is force times time, which I've written already. So impulse, we're going to verify later, Meso. So if it gives us the same dimension, that means we're correct. So that's going to give us what? MLT minus 1. Do we agree? Because this one has 1 here. Do we agree? Do we agree? Hope you know how that minus 2 plus 1 gave us 1. Okay, we have smart guys. So that impulse is the sound of that generator getting to us. Can you hear any other sound in my background aside my voice? If you can, let me know what to do. Okay, you can't hear any other sound. Okay. Okay. So impulse is equal to what? MLT minus 1. So let's verify with momentum now. Just like our friend said. So for momentum how I learned momentum. Sorry for I don't know how to speak that in Yoruba. For momentum, this is how we learned it in secondary school. Our teacher said, people that understand the body, the man said agrema. Like when you put body for somebody, when you are playing ball, like when you put body for somebody. So that was why I can't forget momentum because of that example that man used back then. So momentum, simply agrema, when you put body for somebody. But I don't know how to speak that in Yoruba, but what do you guys call it? When you put, maybe when you are playing ball, anointed, do you play ball? When you are playing ball, then you quack somebody a bit. What's the term for it? Anybody here? Ferrami? This one's not.
I don't play ball.
It seems you learned Yoruba with English. No problem. Who again? Anybody that knows what quacking is? Let's continue. So when you quack someone, okay, even Anointed don't play, but sorry, Anointed is a man of God. He spent most of his time on the church, in church rather. He spent most of the time on the pulpit. Anointed, most of your time is spent on the pulpit. We'll call it me Foxy. Okay, you're from Akwa Ibom. Oh, interesting. Okay, so mass times velocity. No, I stay here. Okay. So now mass times velocity. So that means that momentum is equal to mass is what? M, right? Times velocity is what? Velocity is what? LT minus 1, right? LT minus 1. So that momentum. Yeah, Meso. Can you see it now? Meso, have you seen it now? Exactly. So, but yeah, so impulse is force times time. So you can see that impulse and momentum, they have the same dimension. So it is not bad for us to say that impulse is equal momentum. So impulse is equal momentum. All right. So the next one we can do before it gets to 11:30 is your energy, right? We'll have energy and work, right? Energy is equal to force times by distance. So that energy is equal to force is mLT minus 2 multiplied by L. So therefore, your energy is equal to mL times L times T minus 2. This is 1 and 1. So we're going to make use of your knowledge of your indices, your power law, right? So that will give us mL squared T minus 2. We are correct, right, men and brethren? A thumbs up if you understand what we did here, please. Very fast, so proceed. Yeah, thank you, Titiola. Thank you, Meso. Thank you, Tinonso. Ferami, good. BTC, Justice, okay. The person answering, you've not told me your name, so that I'll stop calling you BTC. Is that Daniel Ayomide? We cannot hear you. I want to know all of you by name. So work is what? Wait, is energy first time distance? Okay, Daniel Ayomide. Are you sure I'm not making mistake? Yeah, am I correct? Men and brethren, what's the formula? Okay, so how about work? Work as well is the same formula, is that also? Yeah, so work is as well force times distance. The next one I want you guys to go and check is moment. Moment is force times perpendicular distance. So that will give us mLT minus 2 times L. So that work is equals to, check for pressure as well. Check for pressure, check for moment. These are sign of conscious you look out for. So this is mL squared C minus 2. So that means that work and energy, they are brothers and siblings. So please take note of all of these things that we are doing. Remember what I said, check out for moment, check out for tau. Let me write it down. right? So energy equal work. So your responsibility, check out for this. So energy is equal work. All right. So check for the all those questions they can ask you. Check for one, check for pressure, check for moment, check for torque. Check for all those gravitational potential. Check for gravitational potential energy. In fact, check for your past questions. Is that okay? Is that okay, guys? All right. So this is for your fundamental quantities, and this is the process, and this is the way we'll go about that. So in summary, we started up with our fundamental quantities. In our next class, we'll be looking at vectors, right? So we'll have your fundamental and derived quantities. We'll have mass, we'll have length, we'll have time, and the rest of them. We'll have our derived quantities. We'll have the key measurement. I've shown you how to measure length. I taught you how to measure mass. I even showed you how to measure volume, right? Measurement of time is not usually asked. I spoke about the precision and reading accuracy. So I said we'll have meter rule, we'll have vernier caliper, we'll have micro screw gauge. So precision is the smallest division or calibration on an instrument. We'll have your meter rule, and I said that the precision for meter rule, the smallest division for meter rule is 1 millimeter, right? And you can convert millimeter to centimeter by dividing by 10, right? And then I said that precision for meter rule is 1 millimeter, and the reading accuracy, just divide that one by 2, you get the reading accuracy. And then I said that there are kind of reading that you can see from a meter rule. When you have something like 30 millimeter, it means that it was measured with a meter rule because you're going to have 0 decimal place. If you have 36 millimeter, it means that yes, it was measured with a meter rule because there's no decimal place. But when you have 1 decimal place, like 3.0 centimeter, it also means that measure will be what? The meter rule. So I went ahead to speak about vernier caliper and the kind of things you can measure with your vernier caliper. I said you can measure external diameter, you can measure internal diameter, you can measure depth. Diameter of a metal rod, diameter of a cylindrical object, diameter of a pipe, diameter of a coin, diameter of a tube. All of these things are the stuffs you can measure using a vernier caliper. And precision is simply the smallest division, which is 0.1 millimeter or 0.01 centimeter. So we have a reading accuracy of 0.1 millimeter divided by 2 for your vernier caliper. And remember that what you cannot measure with meter rule, you can measure with vernier caliper, because vernier caliper is more accurate than your meter rule, right? So now we have another big guy, which is your micro screw gauge. Anything that is thin, small thickness or diameters can be measured using your micro screw gauge, right? So you can make use of what? Diameter of a thin wire, thickness of a sheet of paper, diameter of a small metal rod, right? All those tiny stuffs can be measured using your micro screw gauge, right? And these are the precisions of each of them and how it can be measured. We solved the examples on each of them. These are example 1, example 2, and the rest of them for vernier calipers. I as well did that of what do you call it? Of vernier caliper. So these are example 1, right? This is example 1, which we finished. So that when you get the slide, you'll not be confused. And if you have question, I will know the one you're talking about. This is our example 2. Then this is our example 3. And that's the list that we did right here. So I gave a summary. So just get this slide will be sent across to you, and you are going to get that as scheduled. So this is our example 1 for vernier caliper, for micro screw gauge. This is our example 2 for micro screw gauge. And finally, this is our example 3. All right, any question, guys, for what we've done so far? Any question, anyone? Do you have any question? Ask your questions or forever remain silent. All right, so now I want you to go to this website, joinmyquiz.com. Go to this website, joinmyquiz.com. Let me type it on the chat. joinmyquiz.com. Go to joinmyquiz.com. Can we hear me? Go to the website joinmyquiz.com. Are we there? Good. Now, I will share my screen so that you are going to receive the code shortly now. If you are there, type I'm there. Who is there? Do I have only Chinonso there at the moment? Okay, I'm there. Okay. I have a lot of persons there. Good. I have a lot of persons there. Beautiful. Beautiful. Okay, I'm there. If you're not there, say wait for me. Everybody's there now, right? All right. So I'm going to share my screen so you can take the link and then we'll join immediately. All right. You can be brushing through your notes. Like I said, there's going to be a gift for the person that, Emmanuel received his data yesterday. At least he's enjoying his free data. Is that also? Are you not enjoying your free data? Emmanuel, confirm you're enjoying your free data, my brother. Emmanuel, can you quickly confirm you're enjoying your free data? Yeah, I'm enjoying it. Thank you. Well done. So there will be a gift as well today for anyone that performs the most. Okay, I will share my screen now. Let's see who and who have been following through in these lessons. All right. So take the code now, 5466. Is requesting for a code, right? The platform you are, good. We'll be requesting for a code. Good. So, and the code is on the screen, 5466 3260. 5466 3260. 5466 3260. Type join with your name so I know who is who. Join with your name. Let me know. I have Ayomide. I have Mide BTC has joined. You cannot join?
Yes.
Why?
I don't know, because I not see the code.
Join. Okay, 5466. 5466.
Yes.
3260. 5466 3260. Have you joined?
That did not allow me to type in my name.
Why? Have you joined? What's your name? Anointed? Justice. Check again. You can join with your email or anyone. If it's your email, that's fine. Titiola, have you seen that?
No, so I'm not being able. They didn't allow me to join. I didn't even.
Why?
Oh,
You don't have the
no.
code?
I have now, but like they're not allowing me. They said the code is invalid.
Oh, no, you're not typing the right code. Check the screen. The code is on the screen. I go again. 5. Type 5 now. 5. 4. 6.
No, the enter code is not even working again.
Okay, go to joinmyquiz.com again. Others are joined. I've joined already, and we're waiting for you to start.
Okay.
Go to joinmyquiz.com. The link is on the chart. The link is on the chart. Have you seen it?
Yes, sir.
Good. So now type this code now. 5 4.
So it is blank.
5. What is blank?
Okay, sorry, sir. 5 4.
Okay. 6 6.
3 2
3 2 6 0.
6 0. Okay.
Yeah.
Okay. Yeah. Who's that my name?
I have Anointed is here. Chinonso is here. Verami is here. Justice is here. Yeah, Titiola, you've joined. All right, guys, you can start. Mute yourself, Titiola. Thank you. All right, guys, hit the start button. There's a place that has start button. Hit the start button from your end. Hit the start button from your end. Give me a thumbs up if you started that lesson. Sorry, the quiz I meant to say. All right, beautiful. So let the game begin, guys. All the best. How is it going, guys? How is it going?
Very bad.
Is it difficult?
Kind of.
Hello? Can you just submit? You guys have tried. Submit the quiz. Hello? Submit. Your next class is by 12:30. Mr. Hillary, you can stop the recording. Hello? Submit. Are we done?
Almost remaining 4 questions.
Okay. You guys should be fast. How about others? Anointed, are you here? How about Justice? How about Chilon? So, can we round up, guys? Remember, you have your biology class. All right, we're running up here. Your biology class is starting soon. Is that okay?
Okay, sir.
Yeah. So I will check the highest score, and then the person will receive their gift accordingly.